Good day, class. Welcome back to our course, which is Mathematical Modeling with MATLAB Application. So, last week, what we discussed, actually the preliminaries on mathematical modeling, how mathematical modeling is defined, why is it important, and how do we make use of these mathematical models? Can we really rely on these mathematical models in understanding complex phenomena that we are in? So that's why we as scientists, our job is to actually give or to shed light onto something that is mysterious so that we can explain it in a much more detailed manner and in a sophisticated way po siya that is backed up with evidence. Now, last week, we discussed about how do we define our problem, how do we compose, or how do we search for it, and what are these methods that we need to do in order for us to really properly and appropriately identify the problem na ating gusto studyhan. Okay, that's the focus, defining the problem. And in doing research, mathematical modeling is really important in in analyzing things and also in doing forecasting. So diha man good mas mo actually na ay edge ang mathematical modeling because it can do forecasting and can do prediction as to what will happen in the future given these initial conditions that we have. Pwede man we can do forecasting in a deterministic way and also in a probabilistic way. Now let's move on to what are some examples in doing mathematical modeling in research. Okay, so what we have here is one example of a mathematical modeling where it's very useful because this is really applied this is mostly applied in stocks, in business, wherein we can do forecasting and can do prediction as to what will happen to or the behavior of the stocks to the performance of the business and also the how well the customers will accept or patronize a certain product. Okay, so suppose there is a problem before that suppose you have a revolutionary, never before seen product and you want to release it to the market, right? But the problem is there is absolutely zero historical data on a similar product, so you don't have an idea on that will help you engaging the adoption rate. Kung mo adapt pa ang customer or mo patronize ba ang customer for this product. So what do you do? This is where the Bass diffusion model comes into the picture. It was named after Frank Bass. So named after Mr. Frank Bass it was in 1963. Okay, it was in 1963, wherein he detailed it in his publication on mathematical model in predicting the growth of consumer durables. Now, Frank described the model as follows. It is actually the probability of adapting by those who have not yet adapted is a linear function of those who had previously adapted. So, and the adoption of a certain product, the adoption of a certain product is tantamount or dependent on the adoption sa previous of the previous. Okay? So technically it makes sense because let's say you don't know this product, so what is your major desire man or what's the major factor wherein a certain customer will buy that certain product if it's new, right? So the idea is maybe if daghan ang nagpalit, if others are buying it, then it must be good. So there's that idea there. The adoption of product is proportional or dependent to the adoption of the previous. Okay, if adapt ba ni siya sa mga mag-awat-awat ba, but there are also other customers wherein they are really bold in the decisions, wherein they are risk takers, or maybe they want to try something new, so cutting edge ng mga product. Now this model is similar to other forecasting models. Okay, we are talking about forecasting models such as ARIMA. I think you've heard of ARIMA. So it's kind of similar. Okay, but ARIMA are predominantly, for this case, for this diffusion model, this is predominantly used for growth, for product growth estimation. So, kuan po na siya, dili siya ni stand out ba for predicting how well your product will perform. Will it be successful, or will it have greater sales, great revenue? So, ana siya. So, for the bus diffusion model, so yung sa man niya pag-describe, according to Frank Bass, he computed the probability of adapting at a given time. So, natawag na, what could be the probability of the product being adapted? So, dinigid siya magsugod ang mathematical modeling, analyzing the situation. Then, from the situation, we can deduce some relationship on maybe some factors, right? Na makakreate og mathematical equations based on the analysis that we generated from a real phenomena or a real problem that we consider. So we have, according to Bass, the probability of a product being adapted in time at a given time is given by this equation. We have P plus Q A of T over N. Okay? Where P here is denoted as the coefficient of innovation, and Q is the coefficient of imitators, or coefficient of imitation. Okay? So it talks about kung sa may probability na ma-adapt ang product at a given time. Okay? A here is the cumulative. Okay? Cumulative na siya nga, or customers who have already adopted. Okay? Customers who have already adopted the product. Okay? And this is summed up over time. So, okay, later on. So this probability now, this is actually equivalent to this ratio. So we have N of T and R of T. Okay? So this is actually the ratio of a customers adapted in time. This is the new adoption. Okay? The customers adapted in time in a particular time period to the potential candidate. So this is a potential candidate pool of customers at time T. So kung pa rin wala nag-adapt or nag-subscribe. And this one is the number of customers who subscribe or who adopted the product. Okay? So where R here, or N, we have defined N to be, so that's actually the number of new adopters. So this new adopters in time T. Okay? So ang A is A of T, as I said to kanina, these are customers who have already adopted prior to time T. Okay? So A can actually be written as, okay? So A can actually be written as this one. So actually summation na siya of n of I, where I runs from 1 up to p minus 1. So this is just n of 1 plus n of 2. So cumulative na siya. And so on. Up to n of t minus 1. Where n of t is the number of new adoptions at time t. Okay. Now how about this r here? This is the remaining customers who have not yet adopted. So these are what we call the candidate or the potential pool of customers na pwede mo adapt. So we have r of t is just where m here is the market size. So the total market size minus a of t. So this is the total market size minus the number of people who already adopted. Okay, so where m is market size. So basically, this is just the equation here. So based on what our analysis has given us. So this is the equation of the general equation of the vast diffusion model. Okay, new page ka. Pwede na tayo on this new page. So another whiteboard. Okay. So again, we rewrite our equation for the vast diffusion model. So we have n of 2 over r of t equals p plus q a of t over m. Okay. Again, this is the market size. Your m is the market size. A is the number of customers who have already adopted prior to time t. Q is the coefficient of the invitation. P is the coefficient of innovation. N of t is your number of new adoptions at a given time t, and R is your remaining pool of potentials of subscribers who have not yet adopted the product. Okay. So this right-hand side of the equation, this will tell you, di ba, mao man siya ang imuhang probability of product getting adopted. So kay ulan diri sa ano. Well, the left-hand side of the equation, these are equivalent, the equality sign. So this is the one way of saying of this probability of a product getting adopted is just equivalent to saying that's the ratio between between the number of new adoptions and the potential candidate, right? Or the potential pool of customers. Okay. So from this equation, we can manipulate this one and try to get the n of t because we are interested in this n of t. What could be the number of new adoptions as time is evolving? Okay, let's say we start from time equals 0. How many number of customers do you think will adapt to your product? Let's say at later on at time t equals 10, maybe 10 years. So how many customers do you think would have already adopted your product then? Okay, let's do some manipulations here. We can get n of t by cross multiplying. So we have p plus q a of t over m multiplied by this r of t. Now r of t, we already defined that one as the market size minus the number of customers who have already adopted, right? This is your R. So this is your R of t. Okay. Now we distribute this one. Okay, so what will happen is so we have P times m minus a over a of t plus q a of t over m times m minus a of t. Okay. So this is nana masya kasayo. That's how simple it is lang. So you have your equation here, and we can. So this is the number of new adoptions of a certain product at a given time t. Now these new adoptions, the number of customers who adopted the product at a given time t, is actually it constitutes of two types of people. Kanisya, this is what we call those people nga mga innovators, what we call is mga innovators. And this type of people na nag-adapt sa product, these are what we call the imitators. So innovators, mo to sila mga customer na nahilig bitog something new. Kanang, paano gini, okay na siya nga product na kitaan ni sa market. I haven't seen this before, so I want to try this. So those people are kind of cutting edge. They're looking for something new. They're baga innovators from the word itself. Innovators. So sila ang gusto mag-una ba? Kani, ako na suwayan. Now, for the imitators, these are type of customers na mo-adapt sila because someone has already used it. Someone has made testimonials from the innovators themselves. Nga, niingon ang mga innovators, these are really, I have tried this one. This product is good. So, diha sila mo adapt pa sa product. Maybe because it's good, because it was said by these people. So, word of mouth. Ano siya, wag na pasa-pasa ba nga, okay, that's why they opt to adapt this product. So, at a given time t, that constitutes the number of new adoptions per time. Okay? Per time na siya. Now, we can somehow manipulate this one na that your equation will somehow look like this. We'll manipulate this one in such a way na i-combine na to ang similar terms. I-combine na to ang puros na ay P. I-combine na to ang puros nga na ay A o walay A, because somehow we can see it in this equation. This is some kind of an dependent and then an independent variable. So this is your dependent variable, and your A of t is your independent variable. Okay? So kani siya wala man siya if imo siya i-multiply, so wala ni siya variable. Yeah, that's Pm. This cosmo A distribute lang. That's P A of t plus Q A of t. So, cancel na siya ang m, then multiply sa second term. We have minus Q over m A of t square. Right? So, simplify pa na siya further by having this Pm minus okay. This is Pm plus Q minus P. Kani siya diha. Q minus P times A of t. And this is Q over M A of t squared. So we have now this equation of our vast diffusion model. So kani siya, this is actually equivalent na po na siya ani. Either way, okay ra. Okay? Either of these equations. Kina. But somehow, kani siya is baga meaningful siya in an abstract manner, in in the lens sa mathematicians or physicists, because this equation is kind of familiar and it's solvable, right? Because we have your variable here, and then as a function of a of t. So 0 order, you have your first order here, and then second order, right? So cannot see it. And this equation is reminiscent of this equation, yi equals a plus bxi plus c xi squared, di ba? Ano siya? This is the general equation sa imong polynomial. So we actually go on to higher order pa. So if you cut this one, kaning x squared lang, wala nang x squared kanilang, this is your linear equation, your line, right? Y equals mx plus b or a plus bx. Okay? And then where a here, in our case, a is just pm, and then kana siya. B is just q minus p. C equals negative q over m. Okay? So we have this model, mathematical model, and then we know from the fact na ang process of mathematical modeling is start mo na siya of conjuring your model, and then if your model is correct, there's only one way to find out, and that is to test it with the actual data. What does your real data has to say? If your data will coincide with your mathematical model, or if it does not, then you have to modify back as starting a process, you have to modify your model and then do some changes and manipulations in such a way that your model now will coincide with what the actual data has to say. Okay, so we can run this equation. This is now easy to program, this one. So maka-create ka dapat og graph ana nga this is time and then this is n. Okay? N. Adaptation. So unsa kay graph niya at time t given nga let's say mag-introduce ka unsay ang coefficient mo, unsay q, unsay coefficient p. Okay? So time and time again na ay data nga makuha from the market or from the business sector nga actually they have found out nga unsay mga value nga typical value sa q and typical value sa p. So the typical value sa p mo hover na siya around 0.03. So ang p na around sa 0.03 and ang q is na around sa 0.38. So naraan na. So giunsa ni siya pag-determine, then gikan na siya sa actual data, and then from the actual data imong i-plot, and then you do the fitting here, mo man ang imong equation, then mo ni imong equation sa bus model from the data, and then you do the fitting, you determine dayon from the fitting unsay optimum value sa imong constants a, b, and c, and from there you can get the values q and p. So most of the studies that has been done in the past regarding vast diffusion model as the mathematical model nga paggamit in forecasting, in describing the behavior of a certain product, ayan, adaptability, somehow ang p mo hover siya around 0.03 and q is 0.38. Now as an exercise, we'll try to code this one. So ato siyang i-code kani siya using MATLAB. Usa kay behavior ani niya. Let's say we want to play around with values of q and p. So actually I've already made a program of this, and I will not show the code because you have to do it yourself. So actually sayon na jud kay siya. So isara na siya isa na siya ka equation, and sayon na kay siya i-code actually. So I'll just show you the output, and from the output you have to devise your own code how to replicate my graphs. Okay, so let's do this. So tara. So I actually made a function called bus discrete. Can you see it? And then this is how I run my program. Okay, So let's say na ako'y mo start ko from this value, akong P is 0.001 and ang ako ang Q is 0.5. So Q is 0.5 meaning layo kay diferensya no 0.001 ang P. So it must be nga ang imong ang based from this assumption, ang imong behavior sa imong product adoption is solely ang iyang contribution is sa mga imitators. Okay? If we run this one, ano siya? Okay? So the blue line actually represents the cumulative number of adoptions. Okay? So cumulative number of adoptions. Whereas ang kaning black one, nag-represent na siya og katong new adoptions per time. So pila man ang number of adoptions per time. So as you can see, ang kani siya nga example, 100 na akong example, 100 ang ihang market size, 100 ka total number of possible or potential customers. And then, let's say T here is 4 years, up to maximum 30 years na siya akong set. So based on this simple example, we can actually analyze na dayon nga. We can get some useful insight based on this. So tanaw na to, ang blue line signifies the cumulative adoptions, the total adoptions over time. So as you can see, nag-saturate siya. So let's say approximately at time year 24, so mag-saturate na siya, meaning wala na yung mo-adapt. Na maximum na po siya, 100 na siya ka-customers, right? So tanan, nag-adapt na sa product. Whereas kanin black one signifies the number of new adoptions per time. So pila man ang mga bag-o nga adoptions, kumbaga sa COVID pa ni siya, kani siyang black, muna siya ang active cases na pila man ang cases na dugang kada adlaw. So in this case, pila kabuk ang number of customers na dugang kada adlaw nga di kuha sa product. Okay? So nag-maximum siya diri around year 17 maybe or 16. Tapos nagkagamay na siya until such time nga wala na ini-adapt, okay? Because na maximum naman po siya, mo coincide siya ani. Okay? So, inana lang siya. So, how about if we try to change, so tickle around the values of P and Q. Let's say, ang P na to is 0.05. And then, so mas dako na ang P, then, kaysa Q. So, the Q now is 0.01. So, let's see what will happen. Okay? Ako sana i-close. Let's run it again. So, take a look. Lahi ang iyang behavior, right? So, dako kayo diferensya ang imuhang unsay performance performance sa imuhang product, kung how well man siya ma-accepted sa masa bitaw based on the coefficient of innovation and the coefficient of imitation. So pila man ang mga people sa sugod nimo ba nga mga innovators o pila pud ang mga imitators. So diha ra gid siya magdaog. So kani in this case, ayang behavior is kani halos layo kay ang time nga mag-plateau siya, right? Kani pod ang iyang number of new adoptions sugod siya taas pero dugay siya dugay siya, ang sustainability is mas nindot, mas taas. Okay? Now, you can actually play around with that and let's say exercise. Again, this is time, this is n. Let's say, nakoy graph na nakuha ang ngayon ani. Okay, naana siya yung behavior. This is sa new adoption, sa katong n. So, unsa kaha ang iyahang P and Q ana? Right? P and Q. Sa kaning graph, okay? Graph. So what we discussed sa kanina example is kanina nagsugod ta ani, right? Nagsugod ta ana, and we did a theoretical prediction on what will happen to your product over time. Kung pila na ang number of adoptions, number of people nga mo adapt sa certain product, And we found out nga dependent gid siya sa coefficient of imitation and coefficient of imitation and the coefficient of innovation. Now, in reality kay wala ta kahibawdaan unsa ang P and unsa ang Q. No, sa kanila case, nag-play around naman ta sa mathematical model na to. Atong substitute ang P, substitute to ang Q. Now, in reality, what we have is actually data. So, ang naa sa itong data is, of course, naatay N of T, then naapod tayo A of T. And this is time, right? So, nakuha time 0, time 1, time 2, and so on. Napo na siya value. Na. So, mani ang data nga naa na to. The question now is, based on this data, unsa kahay i-graph nimo na siya, unsa kay P and Q. Right? Unsa kay P and Q. So, pabali na siya when we work backward because in reality, that's how it works yun. Given the data, then we have to determine based on the data unsay iyang equation dapat. So, we can determine the equation if we know what's the coefficient P and what's the coefficient Q. So, we can determine that by using this equation. Right? So we can solve this. This is easily solved using the general least square or the nonlinear least square method. Okay? And luckily, kani siya nga method na siya sa MATLAB naka-built in. Okay? So, mana na siyang i-tickle around. So you can search sa web on how to use the nonlinear least square or the least square method. So, MATLAB. And from there, makuha dahil nimo ang maximum, unsay dapat optimum value sa A, optimum value sa B, optimum value sa C, so that mo-fit ni siya nga equation based sa kaninga data. Right? And once you have determined the coefficients A, B, and C, now it's easy for you now to determine the coefficients Q and P because we have this equation, right? So, technically, that's how you do mathematical modeling. First, you understand the problem, and then from the problem, you devise a relationship between factors or mga key players na nag-involve sa kanang problem. So, in this case, so for vast diffusion, you have your product, and then from that product, na ay mga customers nga mo-adapt ba ng product or di, or mo-adapt ba sila based on someone has told them or na nag-iwan sila handot ni siya nga product so they can adapt. Kaya na po ibang customer nga mo-adapt siya kay ganahan na gid siya. So inana siya. So from that, we devise an equation based on this. So na kay equation nga of this type, it turns out nga ang iyang form is nag-follow siya ani nga form, which is the general equation of a polynomial. Okay? And general equation of a polynomial of order 2. We have a plus bx plus cx squared. And kani siya, dali naman na siya isolve. And if we have this data, so we can immediately do forecasting if we can determine the P and the Q. So how do we determine the P and the Q? By doing a fitting. We can fit the data based on the equation that we have. We can solve it using the least square method, the nonlinear least square. And this nonlinear least square is already present or built in MATLAB. So, for your case, I want you to replicate what I did sa ganina, kato mga graphs, ani. So you can create your own program based on this equation, kani. Make a program based on this equation, and then later on I will give data, dayon, actual data, and then you will be the one to determine the coefficients P and Q by solving this nonlinear least square. You see, this is just a nonlinear least square problem. Okay, so that's it for vast diffusion. It's a very simple model, but it has a great impact sa society, especially in the business sector. Okay. Deciding factor man na siya if mo-release ko nga product unsa kay possible scenario nga mahitabo, will this product be accepted, will this product be successful, if successful siya until what time, until kanus siya nga magpabilin sa market. Okay, so that's our job as a data scientist or even physicists nga makahatag ta og foundation to these people nga it's kanina ay go signal ba nga okay ni siya kani nga product because based on the market we have this kind of people, we have the innovators and we have the imitators. Okay, so simple pa ni siya actually nga model because ideal pa man ni siya. Our P is constant, our Q is constant kana siya. So later on daghan mga studies pa gyud nga gi-extend ni siya into a more realistic way. Mas complicated siya and mas complex ang iyang equation. Of course, mas complex ang equation because in reality, ang nature, di ba? Ang nature is, dili man simple ang nature. Ang nature is complex. So, if it's complex, it will require us more sophisticated and complicated or complex equations for that matter. That's all for now. And I'll just be posting your things to do for this chapter, for this lesson. Okay? Bye and stay safe.